Hi. Well, like Catherine said, I'm Dan Chouinard. Little history, I moved to Arizona in 1959 from Chicago. My father was a carpenter, and I went to work with him a lot, even at a young 6- and 7-year-old age, and got to see a little bit of construction. Even before we moved here in '59, and you guys are probably aware of this, pretty much everything was adobe, and vap coolers, if they even had that. The adobe was raised off the ground so the air could flow underneath, and they had windows up high to let the hot air out. And then they started mass producing houses, and adobe wasn't cost effective, so they started using CMU, concrete masonry units, or concrete block, to build houses. And even then, the house we lived in '59, it had concrete floors, it had exposed CMU walls, and vap cooler. And what you did is you ran the cooler all night and tried to cool the house off as cool as you could. And then about 8 o'clock in the morning, you buttoned it up and just tried to live off that thermal mass all day, because the vap cooler really didn't do much, as you probably know. In July and August, when the monsoons get here, you just can't put enough water in, or the air won't take any more water. So then over the years, they decided that to make it more comfortable, I think it was Motorola had the first air conditioning units they put in. Cost of living was so cheap here, they wanted people to come out here and work at their plant, but nobody wanted to live in Arizona without any air conditioning. So as far as I know, I think the Motorola plant in Phoenix was the first place to have air conditioning. Well, then they started air conditioning the residential houses, and at that point they felt they needed to do something to keep the heat out. So the first insulation that I know of is foil back drywall. And it was just the same drywall we have today, but it had a sheet of tin foil like on one side. It's very similar to what they have now. It's called Tech Shield roof sheeting, OSB, that has a foil back on one side. It did a little bit of insulating, but not much. So after that, they decided they were going to put insulation between the furring strips they put on the inside of the wall. And they would put 3/4 inch of expanded polystyrene or styrofoam between the furring strips and use that for insulation. But utility bills were so low back then that nobody really cared about it. Well, as things developed on, they decided they needed to insulate a little better, so they started putting what's called zoolite down in the concrete cells. It did a little bit, but not much, because you still had that thermal bridge through the concrete block, and the heat would transfer through that bridge into the house. So after that, all of a sudden, somewhere in the late 80s or late 70s, early 80s, they were building with stick frame in California and a little bit in Las Vegas. At that point, they said, well, we need to do that in Arizona. So the track builders here and a lot of the builders here switched from concrete block exterior walls to stick frame, and they put an R13 fiberglass insulation in it. The problem with it, the air infiltration was just horrendous through all the light fixtures or all the switch boxes, doors, and windows. So as it progressed, they went on in and they started making better windows and sealing around the outlets and what have you. Well, during that period of time, the ICF was invented. The first ICF was invented in Austria, and they just took a block of styrofoam and had a piece of stovepipe, heated it up, poked holes in it, and it was very similar to my product, the screen grid, that we're going to get into in a minute, but it was pure styrofoam. So that eventually developed into the ICFs that are on the market today. Well, going back to my history, I started framing with my dad in 1969. I was 16 years old. He opened up American Framers. I worked with him through school and finally graduated from high school and went to work full-time for him. In '75, he decided he wanted out of the business, so I took over the company in 1975. And again, we were building, all the houses were concrete blocks, so all we literally did was build the interior partition, set the roof trusses, put the plywood on. That was the extent of framing in those days. Well, then, like I mentioned earlier, somewhere in the late 70s, early 80s, stick frame or wood frame exterior construction came in, and we started building the houses out of stick frame. Well, I've been contracting since 1975 on my own, and I've lived through a lot of recessions. The savings and loan fiasco with Charlie Keating, interest rates going through the ceiling, and all the different recessions we went through. In 1989, 1990, that was the savings loan one with Charlie Keating. There literally was nothing to do. We had about 180 carpenters, and there wasn't any framing jobs. So we're sitting around twiddling our thumbs. I said, there's got to be something better. So at that point, I started researching alternative building material. I don't know if you guys know Barbara Mandrell. Her song, She Was Country When Country Wasn't Cool. Well, I was really green when green wasn't cool. So we started researching products, and I came on this product called Rastra that was very similar to this ICF product we have here. It was a 15-inch on center composite block. It was 10 foot long, 15 inches high, and 10 inches thick. This is a half of one of our blocks. The full block is 5 foot long. This is 2.5 feet long. Again, it's 10 inches thick and 12 inches high because it's a 12-inch on center screen grid. I'll kind of jump around a little bit. There's 3 different ICFs on the market today. One is called the flat panel or flat system, and that is styrofoam, solid concrete, and styrofoam. The other one's called a waffle grid. I don't have pictures of those, I should, but it looks just like a waffle. There's a post and beam with concrete in between, a thin layer of concrete between them. And the final one is the screen grid, is what we have. The Rastra block was difficult to handle. Again, it was 10 foot long, weighed about 125, 150 pounds. It was pretty tough for one guy to handle it. And again, in 1990, when there was nothing to do, I started distributing that and installing it. A lot of the customers were complaining about the length of it and what have you, but we just had to live with it. Well, then over the years, Rastra changed its name to Perform Wall. There was another company come in town called Apex, and they put a plant over on Fillmore in Phoenix. Went through all of that. I was distributing for all of them. The problem with them is their manufacturing facilities cost between $10 and $17 million. These guys were already so far into the red when that recession hit in 2007, they just couldn't weather it. And I seen the handwriting on the wall, and I developed my block years earlier, and when I seen them going and we got in that recession, there wasn't nothing to do. So in 2007, I started making my block. We are virtually the only composite ICF left on the market today. And when I say composite, it's because our block is made of 87% recycled styrofoam. So styrofoam that would normally go in the landfill, we intercept it, grind it up, and make brand new building blocks out of it. Some of the people that bring us foam are ASU, Mesa Unified School, Tempe Unified School, Maricopa County Health, a couple of pharmaceutical companies. Then we have collection bins at ASU and in Tempe at my office where people regular citizens drop off foam. There's one lady, I should get her name, but she lives in San Diego, believe this or not. And she comes over a couple times a year to visit her family, and she's got this little Subaru SUV, and she literally stuffs it full of styrofoam and shows up in Tempe and throws it in my bin there in Tempe. The problem with styrofoam, most of you may know, the recycling bins, it's not a recyclable product. So it's not supposed to go in the blue barrel. It's supposed to go in your garbage. Well, you take it to the dump and bury it, it's like burying tires. The ultraviolet rays don't get to it. It doesn't decompose. It'll literally be in that landfill forever. So I'm working right now trying to get it where we can divert it from the landfills. But man, it's an uphill battle. If it costs them a nickel, they don't want to do it. So it is something we're working on. I am working with a customer, Warren Crawley, in Tuskegee, Alabama, believe that or not, and he's putting in a new recycling facility because they don't have one. And he's going to implement the recycling of the EPS, and we're putting a manufacturing facility there. Right now we have 3 manufacturing facilities. The original one in Tempe, we have one in Cabo San Lucas that I really like to visit, and then there's one in Kingman, Arizona, which is a brand new 200 or 110 mold plant that's capable of doing 220 block a day. We'll be opening the one in Tuskegee, one in Portland, 2 in Florida, and 1 in New Jersey sometime in the next 12 months. So, with that said, I'm going to flip on a video of, I think I'm going to walk over here and do that. Can you, Kip's house or Eddie Wong's house? This is a video of a movie theater, a home movie theater we did in Tempe. The homeowner is Eddie Wong. He was the general manager at Monty's for 35 years. And I was talking to Michael Monty a few months ago, actually more than that. And Michael said if he'd known how much Eddie was going to come down to Monty's after he had retired, I would have fired him years ago. So it's kind of a joke, but anyway. And my video guy, he thinks he's Steven Spielberg. I don't know if you've seen the Star Wars stuff go by. Where we're at right here, this is, the footing's already poured, and we're squaring up the building to put it on the footing. Always helps if the building's square when you go to put your trusses and your drywall and roof sheeting and what have you on. They're popping lines there after they got it squared up exactly on the footing. Right now we're shooting the footing to find the high point. You want to take the block and start at the high point, and you can always shim the block up for your stem wall. It's easier to shim it up than it is to try to cut it and rasp it down. That's Eddie in the background there with the shovel. Right now they're going to start setting the block. This guy's name was Justin. By the way, everybody working on this job was the first time they'd ever touched the material. And Justin, this guy, he had to shave a little bit off to get it the right height. We had a little bit of a high spot there in the footing. It was Justin's first and only day. He was from Ohio, Akron, and it was 113 that day. The poor guy, I shouldn't say this, but he vomited 3 times and I thought he was going to die on me. But anyway, when you put that first course down, you want to get a little bit extra glue down there. You'll see you don't use that much when you get with the wall. That's a minimum expansion, high adhesive polyurethane glue that they're using there. And then because it's a stay-in-place form, you can go ahead and put a lot of dirt up against it and get it exactly where you want it, because you're not going to have to come back later and remove the forms. Alan, can you get over there? Because we're going to have to pause this every once in a while because it goes too fast for me. All right, thanks. So right now, again, they're setting it. You can see, well, we needed a block and a half. We needed 18 inches to achieve the right height. So we took a full 12-foot block and then ripped the block in half and then set it on top, and then took that rasp and smoothed it off. This is gun care. When you change the gun, you want to clean off the basket, screw on a new gun. That way you don't end up gluing the gun to the basket and you can't get it off. And then every once in a while you got to take a razor or a keyhole saw and clean off the end of your, can you pause that? Well, we almost got it. If you could see here, it kind of went out of the way, but what we had to do, because that footing was about 4 inches low on that corner, we had to shim the block up. You can see it right here and a little bit around the corner there. Okay, go ahead and let it play. Now let's pause that for a minute. What we did, because we didn't want the dirt to go underneath and cause a void, so the grout or concrete that we were pouring on the inside, we didn't want that to contaminate it, so we took scrap pieces of block and glued it along that edge, so when we grouted it, the grout wouldn't come out and the dirt wouldn't go under, okay? So right now, the stem is all set. Oh, now we're going to put a corner piece on. We have a end block too to terminate the wall. And what you do on the end blocks, you cut one ear off and then place it there where you want it. And then we get these 6-inch aluminum spikes, gutter spikes, and kind of hat pin it where we want it to go. And then you can spot glue it and keep it in place. Now that stem's all set, ready to be poured right now. You can see the dirt kick back, making it nice. This is grouting the stem. You want to put a 2,500 PSI 3/8 minus aggregate at an 8-inch slump grout in this footing when you pour it. the footing's all poured. Now they're going to pour the concrete floor. And this is the same as any construction site. Just put it down, run the bull float on it, and finish it off. The rebar on that was 48-inch on center. Now we're unloading the block. Instead of bringing a big tractor trailer over, we just shuttled over from my office what we needed. We're only a few blocks away. They're going to pull the protective caps off, pop a line, make sure that the wall's straight, and then they're going to build a lead at each end and then just follow the string. They're popping the line now. And again, these blocks weigh about 45 pounds apiece. And the thing about the bigger block I was talking about earlier, if you're on scaffolding and you got a 10-foot block in your hand, you can't turn around without banging the wall or banging the scaffolding. And again, now they're going to build a lead at either end of the wall. And you see the spot gluing. You just stab the gun halfway into the skin about every 12 to 18 inches. Give it a little spot of glue, and you get the mechanical bond of the glue expanding into the pores and the chemical bond from the adhesive. You've seen him take that Swanson speed square and mark the block. You can't do it with a pencil or a pen, so you either use a keyhole saw or one of those 6-inch spikes. Now again, he's setting that on there, checking it for plumb. Now they're going to run a string. If you see in the background there behind Lindsay there, you can see they already have the lead built at either end. And now they're going to pull that string down right where they want it. And it's 3/4 inches a wall away. They just take a 3/4 board and follow that string all the way down and set the block. And you're going to see, in order to fill it in right, they needed a 1-foot piece. In this next shot, you're going to see Lindsay slipping that little 1-foot piece in, and bingo, all the way across. So we had 3 guys that had never touched the block before. The first day, this building was 22 by 40, and they had it up 5 foot high, a little more than 5 foot high, the first day. And those are the doorways there. They haven't rough cut that. Could you pause that? No, that's all right. If you see right here and here, these 3 blocks that are stacked up, those are kind of tacked in place. That's the bracing to keep it from blowing over. As we all know, you go home at 1 o'clock in the afternoon, it's 116, and that night a dust storm comes in, and this stuff, you don't need to brace it to keep it straight, but you don't want it blowing over and get there the next morning, it's all laying down, okay? And going back to the doorways, you can just leave them rough and then come back and cut them. Windows, you can't do that because you don't want the debris falling down in the cavities and creating a void when you grout it. This is Alan throwing a corner piece on now, and we developed these staples. Instead of using wood bracing or wood kickers to keep the ends on, we developed the staples. As wood, once you let it sit out in Arizona for a couple days, it's so twisted you can't use it for anything else. Now, if you notice, that wall's 8 foot high, and there's 2 5-foot corners on there. That's what, going to 10 foot, that's why it's sticking above the wall. That's a, can you pause that? That's the, these are the dams. Whenever you put an anchor bolt in any ICF, not just my composite, that anchor bolt, you need to cut a 4-inch hole in. So the grout comes all the way to the surface. So that ledger board is being sucked to the grout and not to the ICF, the composite ICF. And the other thing you don't have that is that anchor bolt cantilevering in that ICF. So what they did there is they cut the 4-inch holes, and then they made the little plywood dams to put over it, so when they grouted it, because none of this wall's grouted yet. If you can see these access holes here, about every 8 to 10 feet, halfway up the wall, we cut a 4-inch hole in the wall. You take that plug off, turn it around, and tack it on the wall with one of those 6-inch gutter spikes or aluminum nails to keep it in place. If you set it on the ground, some laborer is going to throw it in the dumpster, and then when you grout the wall, you're going to have to fabricate a plug to put back in that hole. Okay? Now you can see the access holes cut there in the wall in the corner. There's another one right there. Now the grout truck is, or cement truck and grout pump is here. And again, it's 2,500 psi, 3/8 minus aggregate at about an 8-inch slump. So now they're filling those access holes. So what we're doing here, we're doing 2 4-foot lifts, but we're doing it all in one day. That way you can get the wall up above the penetrations, your doors and windows, get it all racked and true and straight, and then come back. Now they're topping off the wall and grouting the top. Can you pause that? Oh, back it up a little bit and pause it. All right, you see, whoop, all right, perfect. Now what we do is we take 4x8 sheets of 3/4 inch plywood. We rip 4 10-inch rippers out of it for the bucking. That leaves you an 8-inch off-fall. You rip that 8-inch off-fall in half and you have 2 4-inch pieces. So this is the 10-inch 3/4 inch plywood around the edge, and then these are the 4-inch off-falls that we corner. So you build your door and window frame, get it all square and true, and push it right in the opening. And it's a little hard to see in this picture, but there's some 1/4 inch lag bolts that are drilled in and sticking into that empty cell. So when that grout goes down in the wall, it'll go around those anchor bolts or lag bolts, and that's what holds the bucking in place. Okay? Where? No, go ahead. You don't need to vibrate it. If you get an area where, can you pause that? You don't need to vibrate. If you get an area where the grout isn't going down, then you do what's called rodding it. You take a piece of the rebar and just go up and down with it till the grout flows. One of the things I don't think we have in this video is probing. When you're grouting and you're putting those, maybe you've seen it in the video, I was looking the wrong way. When you put those plugs back in for those access holes, you glue it back in, put a nail and hold it in place. Well, then when you're grouting that second lift, you have a person going around with a keyhole saw. They're watching the plugs, make sure the plugs don't pop out or blow out, and they're probing the wall and wiping it off, making sure the grout's flowing through the wall. And what you were just seeing a second ago, I was up there measuring the anchor bolts. So it's very time consuming to measure, locate the bolts, transfer the dimensions down to the guy that's laying it out on the ledger board. And that's what we're seeing now. Go ahead. We pop the line on there. We're taking those dimensions and transferring them down to this board. This is more of a traditional way of doing the ledger board. This is the mezzanine above the where the projector sat. And then there's another roof that goes on top of this that we did a different way. And right now they're putting the bolts on. Everything's done up on the scaffolding. It's a lot harder to work up on scaffolding than it is, of course, on the ground. That's the mezzanine all done. Now we're working up. This building again was 22 by 40. It went from 16 foot to 22 foot. Eddie's got a bunch of old 35 millimeter reel-to-reels, and him and a group of friends, they go from house to house. And can you pause that? I back it up a little bit. I'm talking too much and not following. All right, right there. If you see this wall rakes. Well, what we did there is laid the block on the ground, got it all nice and straight, and then popped the line and pre-cut all those pieces on the ground, and then put them up on the wall. That string up there is what we're using to keep it straight. Okay. All right, pause it. This is a different way of doing it. What we did here is we located where the anchor bolts. Remember I said you had to do the 4-inch hole so the anchor bolt could go in there and it wouldn't be cantilevering in the skin of the block. Well, this ledger board, they required 2 bolts, so we did an oblong or rectangle hole right where every one of the bolts are going to go. The plywood you see on the top here, that plywood is sticking up 2 inches higher than the block. That way when we grout it and screed it, we got a solid concrete cap on the top. Okay? Again, this building is only grouted to 8 feet right now. It's 22 feet. Can you pause that? It's 22 feet at one end and 16 feet at the other. This is a manufactured timber, an LPI, TJI, Louisiana Pacific, Orpac, several other different people make manufactured timber. I like to use them because they're nice and straight and they don't twist. If you get a treated 4x 12 or a 3 by 8 or 3 by 12, and you lay it out in the sun in Arizona, in a couple of days it's twisted, and you can't hardly keep it on the wall. Plus they come 66 feet long. Now you can't haul a 66 footer very easily, but again that building was 40 foot, so we had two 20-foot pieces, so we set two pieces of ledger real easy. Another thing we did is we laid everything out and put all the hangers on and all the bolts, everything on the ground. So we're literally working down on sawhorses instead of up in the air, 20 feet in the air, trying to do that. Okay, let it play. All right, this is a little bit better angle, if you can pause that. Again, we have the joist, the bolt, joist, bolt, what have you, or the joist hanger. Being a framer my whole life, every time we come on a job site, the anchor bolts were 2 foot on center, our trusses were 2 foot on center, and every truss hit on an anchor bolt. Well, Simpson, the joist hanger company, they have ICC or ICBO reports, or testing done on their hanger. They don't want you to take a pair of tin snips and alter their hanger to get it around the bolt. But by thinking a little bit of ahead and placing the bolts opposite of where the joists are going to go, then it just makes everything neater and cleaner. Okay. Oh, one other thing. At each end and one in the middle, in lieu of putting the anchor bolt in, we put a 14-inch piece of all thread. So we're going to take this ledger board and set it up on the wall, bolt it on there, suck it up tight to hold it where we want it, okay? Oh, you can pause that. This again, just let it play, and I'll try to tell you a little quicker on the pause. I think it shows it again here. Again, see how neat and clean that is? And all that work, all right, pause that. This is a good one here. I can't hardly see it, but I think it's, no, it's over here. Yeah, right here, that's a silver one and another silver one. Maybe you can see it. Those are the all threads that go all the way through. These kickers you see here, we pop the line up there, and those kickers are holding that ledger exactly where we want it. Go ahead. Oh, you can see the access hole down here where it's still not grouted. There's no grout in that wall. See the access holes? Pause that. All right, this is a good one here. You can see the kicker here, two of them here because there's a joint, and then there was two more on down. And again, you can see the access holes, there's no grout in it yet. So we did all that work on the ground, slammed it up on the wall. So, and then we even ran the joist, put the blocking in, and decked it with no grout in the wall. And you'll see in a minute, well, that way when you're grouting this 22-foot high wall, you don't need to do it off scaffolding. You can just walk on the roof and fill it with grout. Okay? That's Jason Diaz, the engineer. And now, like I mentioned, we didn't get any video of filling the access holes, but now they're grouting the top of the wall and they're just walking up on top of the plywood. This is mechanical, just hanging from the ceiling. This is about over, and we're going to see a little bit on the electrical. This is electrical. What you do, can you pause that? What you do on the electrical is after it's grouted, then take a Home Depot $39 chainsaw and just cut it into the skin and let it bounce right off the cores. The skin's 2 1/4 inches thick. As long as that wire's 1 1/4 inches deep, it'll pass code. And that's what Eddie's going to do. This is Eddie. He's just doing a demo right now, but for the video guy. Go ahead. So he's taking that chainsaw, hogging it out, pushing the wire to the back, put the spot glue with a little glue to hold the wire to the back, and then it's done. And now you see him glue it. Then he's going to take a hacksaw blade and trim the glue off right here. And that's it. Now, if I would have done it, I would have put all those wires in one cavity, but Eddie, he did that himself. And Alan thinks it looks like the old computer deal, would you? Yeah. If you want to go to the one that says Real Rico. I have these CDs. I'm going to put them on the internet. One thing I'm lacking is a good, a good IT guy. This Real Rico, we went down there last summer. I think it was about a year ago, August, and we did a class in the morning. Had a good turnout. God, there must have been 45, 50 people there. And then in the afternoon, we donated this banco or bench to the community center. They did a butterfly garden and had one of the city officials there. You'll see that in a minute. There's the butterfly. And in the beginning, it was like an anthill. All 40-some people that went to the class wanted to help build this wall. And I mean, 3 guys could have done it twice as fast as 40 can. But anyway, we got it up and it was a lot of fun. There they were unloading the grout. And what you're going to see here is how you can use the scrap material. A lot of our customers, when we're done with building the house, will leave the scrap and they'll do their own barbecue, their own banco, their own water feature. It's just kind of good to say I built something not only by themselves, but they built something environmental friendly. And now you can see here we're kind of putting the pieces together. To build this little banco. It's actually quite large. It was about 11 foot long.
We're going to glue these on here.
And this shows how versatile, again, we're using those gutter spikes or 6-inch aluminum nails. One thing I want to mention, anything that you put in the wall should be either aluminum or galvanized, because if you should get some moisture in your wall, then that rust would wick out into your stucco. When I was doing the rastra, we sold some block up in Desert Highlands, and the landscaper was putting the block up, and they were mitering the corners, 45 in them, instead of using the end elements. And he took little number 4-3 rebar and cut 12-inch pieces and drove them through the corners like hat pins. Well, about 2 years later, I got a phone call from the homeowner that said my block was rusting. And I said, there's nothing in my block that can rust. So then we tear a hole in the corner to see what it is, and sure it was the rebar. They're mixing that up. I'm just going to talk a little bit while this is going here. We did the SEVG Medical Center for Scott O'Connor, Sandra Day O'Connor's son. He represents a group of doctors. We did the one in Fountain Hills on Saguaro and La Montana. We did another one in Scottsdale. But the one we did on Dobson and the 202 South, after they moved in, it's really a beautiful building if you ever go by there and see it, SEVG Southeast, I don't remember what it stands for. When we got the building done, the doctors moved in and they were hearing things through the sound walls that they normally wouldn't hear. So they thought there was something wrong with the sound walls. So you know how it is today, everybody's suing everybody and everybody's blaming somebody else. They had all these specialists come out and they tore holes in these sound walls to figure out why they were hearing through them. Well, finally it came out that the walls were built right. So the final determination was our walls were so soundproof on the outside, there was no ambient noise coming through, and they were hearing things through a normal sound wall that they wouldn't. You seen them there, they were bending rebar to go around the corner. Now we're grouting it. It kind of dwindled down to about 5 or 6 people at the end of the day. You probably seen them cutting it with a handsaw, sawzall. This is the neat thing about the block. If you're putting real stone on our product and the stone doesn't fit right, you can take a claw hammer and hog out the back of it and stick it in there and get a nice, beautiful stone finish. This was where they had me stand there for about 40 minutes and hold that block while they were talking. A couple other things we did. You guys know what snake oil is? You know, remember the guy in the old cowboy who was standing on the back of the wagon? Well, sometimes when I'm talking about my block, I feel like I'm selling snake oil, but it's not. It does all these things. It literally is a cure-all. It's an R40. It's 5-hour fire rated. We built a house in Nutrioso, when that Alpine fire went through a couple years ago and just burned all the houses, tore everything up, this went right over his house. He had our block and he had a metal roof, and the fire went right over. Al, he's an architect in Tucson. I called him up. I said, man, Al, how'd your house do? He said, it's fine, perfect. And he's an older guy, 70. And I said, God, you got to be happy. He said, I'm devastated. He said, now I got this beautiful home in this burnout tundra. And he said, I'll never live to see it green again. But all of his worldly possessions were there. We did another one in Yarnell. Matter of fact, we've got 2 houses coming up from the Yarnell fire. It didn't come out as good. That fire was a ground wind-driven fire, where the one in Alpine was up in the top of the pine trees. And the block is still standing. Matter of fact, we went up to visit the site afterwards. Our block is the only thing standing. The concrete block got so hot that the block literally exploded. There was boulders, granite boulders as big as 2 of these tables. And those boulders got so hot that 2-inch wafers of the block literally blew off there from the moisture in the granite. He had an engine block sitting there with the studs on the engine block. It showed melting on them. He had a fireproof safe that was nothing more than a puddle of molten metal. Right, Alan? I mean, it was crazy. His name's Phil Lobeck, great guy. Like I said, we're building his house, 2 houses for him, and another one for Mike up there. But he had added on, he had concrete block, and like I said, it was still up there somewhat, but it had literally exploded. Just let that play if you would for a minute. He had stick frame that was gone. He had a little shed he'd built on the back of his garage out of metal studs, and it was gone. But the block was still there. It got so hot that the stucco blew off it. He'd plastered the inside, the stucco the outside. It got so hot that the stucco blew off it, but the block was still there. Mold and mildew proof, fireproof, bug proof, soundproof. It's just really a great product. If you want to go to that slideshow, we'll show that a little bit. This kind of moves on its own. I don't know if you're going to be able to stop it. It's kind of slow, but I think we should be all right. This is what's in the slideshow: the introduction to the block, overview, our patent, and then there's some homes built with it. You'll see some of our manufacturing facilities. The slide's supposed to run for 1 9-second segment, but it runs for 3 of them. So it's 27 seconds. Oh, did it go? Yeah. This is the bullet points. Again, we put 2,300 degrees on the wall for 4 hours and then hit it with a fire hose in our testing. That's the plant in Tempe. That's 27 mold, well, 32 mold plant. This is some of our molds in Tempe. That might be the one of these slides sticks for a while. This is the styrofoam. Again, we get it from everywhere. Those big ice chests in that top right one, most of those come from Maricopa County Health. These are our silos and our grinders where we grind up the styrofoam. This is block ready to ship. Can you pause it? This is block ready to ship. The Raster and Perform Wall and Apex, they came on flatbeds. And by the time you'd run straps over it and ship it, the straps would be tight, and then half the block would be broken. So we went to palletized, shrink wrap, put them in the back of a truck. That's one of the things, going back to the plants. The Raster plants were $10 million, but that was back in the early 90s. Today they'd probably be $15, $20 million. The Apex plant was $17 million in Fillmore. Their plants were all these mega plants where they were going to do 300-400 block a day and ship them all over the place. Well, by the time you put a bunch of block on a truck and ship it 1,500, 2,000 miles, your carbon footprint's destroyed whatever green or was ever built into it. So my vision is mini plants. Like for instance, 3 to 5 in Arizona, one down south in Tucson, one here in Tempe, the one up in Kingman, because that can go into Vegas and go into Utah, and that's my vision of these plants. And kind of a, you know, you bring in the styrofoam and we'll grind it up and make you a block deal. So go ahead. This is the La Paz or Cabo. La Paz is about 100 miles from Cabo. This is the Kingman plant. It's really a beautiful facility. And this talks about the block again. If you guys want to shoot me an email, or I think we've got a thing, if you want to put your email address on it, I'll shoot you some information. This is the concept and some of the specs on the block. I talked earlier about the 3/8 minus aggregate, 2,500 PSI.
What got me was the example you showed of that ballpark building in Fountain Hills, where you did outside and there's no windows.
Right.
Can you talk a little bit about
Right. Well, that goes back to the thermal mass I touched on earlier. Back in the 50s and 60s here, there was no air conditioning. So what they did was try to get it as cool as you could, and then button up the house and try to make it through the afternoon. One of the first greenhouses I ever worked on or seen was actually in Mesa, and Mesa's not really green. I don't know. We've done very few houses. We've done more in Chandler, Gilbert, any city but Mesa. I don't know what the thing is about Mesa, but we don't do a lot of green building there in Mesa. But this guy, I called it a Circle K house because that's what it looked like, and I was a framer. It had a mansard roof that cantilevered over the front like the old Circle Ks used to do. But this guy built a full basement, and he filled it with 12-inch river rock. And at night, he'd run his VAP cooler, and that VAP cooler would blow down there into that thermal mass, all that river rock, and all that energy would be stored, or coolness, would be stored in that river rock. And then the next day when it got hot, he would reverse the fans and suck the cool air, pull the air through that basement and suck that cool air up into his house. And I thought that was brilliant. And believe it or not, that was probably 74 or 75 when that guy did that. But the expense he went at. Green is not cheap. It's just something that we're going to have to accept. Our block is less money than concrete block, but nothing is cheaper than stick frame. There's just absolutely, we're the only country in the world that builds with stick. Nobody else builds with stick, just us. Why? Because it's cheap. What do people care about? The tract builders, first-time home buyers. How many square feet do I get for how much money? Or how much a square foot does the house cost? And they don't realize what they can save on the end with utilities, maintenance, and all the benefits. Going back to the project in Fountain Hills, that was my EnviroTilt project, or product that was on the walls there. All of the screen walls and stuff was out of the block, but the building itself was EnviroTilt. That's another product I offer, which is an insulated tilt-up system. But it works very similar to where the composite, even though there's only 13% cement in this, it still works the same way. Matter of fact, my home in Fountain Hills, I have exposed concrete floors. I have 3/4 inch or 5/8 inch of plaster on the inside. It's a south-east exposure, so when that sun comes around in the winter, it goes room to room, kind of a U-shaped. That's it down there on the bottom. It's kind of a U-shaped house that, so that sun will heat up room after room and keep it or warm it up. Same thing in the summer though, but when I turn on that AC, we crank that thing down in the low peak hours, and that thermal mass, the concrete floor, the concrete plaster on the walls absorbs that energy, and then in the afternoon it radiates it back. And going back to the Fountain Hills project, we built that project with the EnviroTilt. The low temperature that night was 83 degrees. 113 degrees in the afternoon. We shot the outside of the wall and it was 136 with an infrared camera. The inside was still at that 82. no air conditioning. All we just hadn't set the doors and windows yet. So what had happened is that low of the night before, that energy was stored in that thermal mass. And because we were repelling the environment on the outside, that thermal mass stayed. And this would be the same on a big box store. Matter of fact, when I developed the EnviroTilt, I was watching them build Tempe Marketplace across the street. And they're pouring these 8, 10-inch thick tilt-up walls. Well, you stand that wall up, and this time of year when it's 90 degrees is the low and the high's 110, 112, that thermal mass gets saturated. So that heat goes all the way through inside. So when Walmart or Target or Home Depot or whomever, when they turn on their air conditioning, they're not only cooling the air, but they're fighting that thermal mass. If they would put the insulation on the outside, like my EnviroTilt or even like the EF block, and repel that environment, now that interior thermal mass becomes an asset. When you turn that AC on, it'll absorb that energy and hold it. That AC doesn't kick back on every time you open the door a couple times, because that energy will come out of that wall and help cool the building. So I think we're about done. Did that play around, I guess? Did anyone have any questions? Did I miss anything? Yes. I'm hard of hearing, and that sun's behind you, and I can't read your lips.
Sure. Are you saying that you manufacture styrofoam for your product?
We don't manufacture this styrofoam. We collect and recycle waste styrofoam.
You can get enough in the waste stream?
Oh, we're just scratching the tip of the iceberg. There's so much styrofoam out there. Matter of fact, we don't even go get it anymore. If you want us to take it, bring it to us. In the early days, we were driving all over the valley to collect styrofoam. But see that hole in the ground they call a landfill? Every square foot of space is a commodity. And the sooner that landfill gets filled up, or even that dumpster behind the pharmaceutical company on 83rd Avenue, every time they got to pay to have that dumpster empty, that's money out of their pocket. And if they can get me the foam easier and cheaper, then that's it. A couple of things I didn't mention. We do monthly classes. Our next class is August 23rd at 10 a.m. in Tempe. Again, if you want to give me your email, I'll email you an invite to it. There's some brochures up here if you want to grab a brochure and get our contact information. Last month we were in August, July. We were in Heber last month. In June we were in Tucson. So this is the first one in the valley. It's so hot, people don't like going in the back of my shop, although we got a new cooler and it's a lot nicer in there now than it was last year. So, 205 South Industrial Drive. It's McClintock and Real Salado. Yeah. Industrial Drive is 1 block east of McClintock, and it's just south of Real Salado. No, it needs to say EPS number 6 on the back. There's a little triangle that has a 6 on it. Our grinder doesn't like grinding. It's too dense. And a lot of people, not so much, but occasionally we'll get polyethylene in there. Polyethylene is that real resilient. Sometimes it'll be white and look like styrofoam. Usually it's red or black or some color. And that's ethylene, and our grinder doesn't like that either. It doesn't grind. The EPS just, whoosh, just goes through it like crazy. Yeah, number 6, right. I don't have it. No, if you go to my website, we were on Channel 12 News, and how lucky is this? Remember the snake oil? Well, we built a house or sold the block, and the customer built a house in Tuscaloosa, Alabama. And about 18 months later, the tornado went through. And this thing was only 3/4 of a mile ride. It could have been over here, it could have been over here, but it went right over our house. And it was literally the only house to survive. The only thing wrong with the news clip is Obama was on in front of me. I should have been on first. So, I did go there, like I went to Yarnell, and a lot of those houses that blew away were built in the 60s and 70s, and some of the concrete block buildings that blew down, and there was no grout in them, no rebar. The framing, they had no hurricane ties, and it was poor construction. But there was Starbucks and McDonald's that was built per today's code, and they were gone too. So all we lost was some shingles on one side and a couple shutters. And if you go to the website, there's a video you can click on there. So. I appreciate y'all coming, and go to our website. And I'm not good with the website, and my IT guy in Tucson, Robin White, drives me crazy because it takes him a week to post anything. But I found I'm really good on Facebook. Anybody can post pictures on Facebook. So if you go to my website, it says to see more photos, click on the Facebook. Now I'm going to explain, because you're all going to go home and do that, or go to your computers right now and do that. You're going to notice that I got a bunch of pictures of my 21-year-old daughter's birthday on my Facebook, business Facebook page. That's because I posted them on the wrong one. So, and then I tried to delete them, and all it deleted was the pictures. The posts are still there. So anyway, we're still learning. I do, actually, we've got about 5 minutes. Can you play the free class, or whatever it's called, the training seminar? This is, it's about an hour and 30, 40 minutes, and I start from the bottom, go to the top. You can get out there and cut the block yourself and glue it and rasp it, and it's really a hands-on deal. During the recession, it's not so much now, it's most, or about 50-50, but during the recession, all of the block we were selling were do-it-yourselfers. I mean, people were buying the block and doing it. The industry was in a dump. I mean, even now, I don't understand this. The lots have gone back up, but there's a lot down the street for $380, and there's a house 4 doors down for $440. And you can't build the house for $60,000. I don't care who you are. I'm talking about Fountain Hills, where I live there, but I think it's coming back. So, in our interest, plant-wise, it's absolutely incredible. We've got interest literally worldwide. China, I'm a little scared about. I don't want to tell anybody in China what I'm doing, but literally all over. The Caribbean, Congo, oh, thank you, Alan. We did sign an agreement with Delaney Group to put 50 plants in the Philippines, and that's going well for us. So, yeah. All right. Well, thank you all for coming. If you got another question. No, super. Don't forget the class on the 23rd, 10 to 12. You know, we got a little archery range there. We may shoot some arrows afterwards. So bring your bow if you want to fling a couple arrows afterwards. So, well, again, thank you very much.